So notice on this next one what we're substituting in for. We're substituting in for the I, which means this little piece right here really acts like a coefficient. And so I can literally move it to the front, and we'll worry about it at the end when we're ready to distribute. So now if I start, I would substitute again first in the 1. So I'm going to have delta x out in front, and then f of x sub 1 plus, then I would substitute in a 2 plus, then I would substitute in a 3, and I would keep going until I've substituted in an n. So now it's our turn to write in sigma notation, and we have the pattern. So you need to establish what's changing and what's the pattern for the part that's changing. So when I look here, I notice the numerator doesn't change at all. So, and I like to start with I equals 1, although you could obviously get clever and start with something else. It will make it easier if you start with 1. And so here's what I notice. That, oh, I'm adding 3 as I go up, or I could say that these are also multiples of 3. That's 3 times 1, and 3 times 2, and 3 times 3, and dot, 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 and so forth, 3 times 9. And so I go, oh, well, in every single one of those, there's a 3. And what's changing is the number that I'm multiplying that 3 by. So I'll call that I. And the first time I did in fact substitute in a 1, so that's good. And the last time I substituted in a 9. So that is my answer in sigma notation. And so repeating again, I want to look and see where's the part that's changing. And so I notice, well, they all have a 2 out in front, and they all have a denominator of 8. That's not changing. So let's see, I'll need a 2 out in front. I'll need a denominator of 8. Looks like, ooh, the top is changing, right? So I'll have to figure out what's the pattern as I move. And then the n piece is always a plus 3, so that's not different. And so okay, so now on this pattern, it looks like, I'm going to call it I could call it J or K. It looks like the first time I would substitute in a 1, so we'll call this I, and let's check to see if it works. So the first time I'd substitute in a 1, that would generate that first term, that works. And then of course I would substitute in a 2, oh yeah, that would work, and then a 3 and a 4, and all the way up until I substitute in an 8. And so there it is in sigma notation. They're not too bad. As you do these problems, consistently go back and look at those formulas. As a matter of fact, the more you write them out, the easier it will be to just magically memorize. Okay, so when I look at this next one, I go, oh, that 2 isn't going to change. It's going to be the same every time. So remember, I could just pull that to the front. And then I have the summation of just I. And so I want to go look up what that formula is. And of course it's n times n plus 1, the shortcut formula, over 2. And so I have to look at what's n. Well, n was 20. So the next number would be 21. And of course we go, oh my gosh, look what's going to happen. Those 2's are going to magically cancel. And 20 times 21 is 420. So we're kicking it up a notch, And I don't have a formula for I minus something squared. I only have formulas for I squared, and I cubed. So I have to figure out a way to rewrite this. Well, of course, I can FOIL that. And if I do, I get I squared minus 2I plus 1. And then remember, by my second summation property, I'm allowed to split these up. So I can do each piece by itself, which is going to come in really handy. Because individually, I can do every single one of these pieces. Now, I do want to remember that on this one that has the coefficient in front of I can put that coefficient right in front. But I have a formula for this. The formula for I squared is n times n plus 1 times 2n plus 1 all over 6. And then the formula for I is n times n plus 1 all over 2. And the formula for the constant, so that's this piece, the formula for the constant is just n times the constant. And so now going back, I have to figure out what's n. Well, n was 20. So I have 20, and then 21, and then 41 all over 6. I'll be able to do some cross-canceling there before I start. And then same thing here, I have 20 times 21. Oh, those 2's are going to cancel. Out here I'm going to have 20. And so when I work each of those pieces out, I end up with a grand total of 2,470. And then these last two problems are just applying your summation rules. So go back and look at your properties of summation. And so here, I go, oh, that 4 is just acting like a coefficient, so I can pull it out in front. And then I go, hey, wait a minute, I think I know this. Oh, look at that. I do, it was given. That amount right there is equal to 4. So my grand total is 16. These are the simple multiple choice questions. I hope I get a whole bunch of these, right? And then on this one, of course, I have a subtraction of 2 patterns, so I'm allowed to split them. So I'd split first the front and then the back. And then again, that coefficient I can bring out in front. And then we'll have to see, maybe I wonder if I know anything about this. I wonder if I know anything about this back part. Oh, wait, I think I do. Let's see. That's right. I know this piece is 4. And now when I go back to the given, I look and I say, wait a second. Isn't that piece right there? So I'd have minus a negative 3, which gives me a grand total of 15. Those are kind of fun.